Yes. So daily I'll be sending you 2 to 3 videos I'll be sending. So let's see how it goes. Okay. Now, so we will start with the new chapter today. It's better if you can get your organic book. So start writing the key points in your notes. Okay, so I'll start with the chapter. The chapter is haloalkanes and haloarenes. First organic chapter and very important chapter also from your exam point of view. Okay, now let us understand what are these haloalkanes and haloarenes. You are familiar with alkanes and you are familiar with arenes. No, you have learnt in this last year. These topics you have learnt last year. What are alkanes, students? What are alkanes and what are arenes? What do you mean by alkanes? And what do you mean by arenes? You should answer this now. What are alkanes and what are arenes? Okay, very good. Correct. Alkanes are saturated hydrocarbon. Okay, single bonded compounds. Yes, very good. Like example, like example. One example for alkane. Okay, ethane. Good, good. Ethane, methane. Arenes are the one which has a propane. Very good, very good. So that means you all know what are alkanes. Alkanes are single bonded as you said, and you are giving me example. Okay, good. Methane is an example. Ethane is an example. I've written only one now. Ethane, propane and all that. And it goes on like that. Okay, arenes, when I asked, you all told me the one which is having ring in them. Like example for that is benzene. Yes, very good. Excellent. Correct. Benzene. Correct, no? Now, what is haloalkanes? Now, important for us is what? What is haloalkanes and haloarenes? So, if I take methane, you know how to write methane structure. There's one carbon in the center and then we have 4 hydrogens surrounding that carbon. Correct? There's one carbon in the center and then we have 4 hydrogens surrounding that carbon. So, what will be now haloalkanes? Haloalkanes are, see, halo means what? Halogen group. Halo is a short word which we give, no? But then halo stands for halogen. You know which are the different halogens we have. It comes under group 17. That is fluorine. Then we have chlorine. Then there is a, correct, fluorine, chlorine, bromine is there. Iodine is there. Yes, very good. All of these are halogens. Okay. So now from the alkane, if you take alkane, replace one of the hydrogen. I'm replacing it. I've removed now one hydrogen. So if I remove one of the hydrogen and replace it by the halogen. So generally instead of writing all of this, we can represent this by X. Okay. X is a general way of representing it, where X will stand for chlorine, bromine or iodine. So if I replace one of the hydrogen by this halogen, what you get after that is called as haloalkanes. Okay, what you are getting after that, this whole thing, okay, this entire thing will be called as haloalkanes. Did you follow what I said? It can be by replacing one of the hydrogen or by replacing two hydrogen or three or all four hydrogen. If you replace by the halogen, they are named as haloalkanes itself. Similarly, now what will be arenes? Arenes, we will take benzene now here. To understand arenes, I am taking benzene. Benzene is having 6 carbon and 6 hydrogen. Correct? No, this is how benzene structure is. But you know, every vertex over here, the 6 vertex what is there, the 6 vertex over here consist of carbon. This vertex is made up of carbon here. Correct? No? These are the carbon. And attached to that carbon, we are having hydrogen. Attached to this carbon, we have hydrogen like this. Okay? So there are 6 hydrogen attached to 6 carbon. So now from this benzene, if you remove one of the hydrogen, you remove this hydrogen and replace it by the halogen, then that will be called as a haloarenes. Okay, I have replaced this H by one X. Okay, that will be called as haloarenes. So when you replace and write, it will look like this. Benzene you are having, and then one hydrogen was removed, and now there is a halogen in that place. Okay, so generally we represent it like this. So don't think that the halogen has just come over there. It has come by replacing one hydrogen which is there, which we don't show. Okay, it's already there. So we are removing that hydrogen and we have put one halogen. Did you follow this much what is said? What is haloalkanes and what are haloarenes? Everyone? Yeah. So basically these are derivatives. These will be called as derivatives of alkanes. Okay. Alkanes are the parent one. From the parent, we have removed one hydrogen and we have put one halogen. Now there's a general way to represent this. Haloalkanes, okay, also called as alkyl halide. This is a common name, okay. Common name is alkyl halide. Because if I have to condense and write this, see here CH3, CH3 and then X, correct, no? So CH3 is what group? Alkyl group it is? Methyl, no? CH3 is methyl. Generally, it is called as alkyl. Okay, so it is called as alkyl halide. So we write it in this fashion, R and then X, where R can be any of the alkyl group. It can be a CH3 group, it can be C2H5 group, or it can be C3H7 group. Do you remember alkyl and alkane difference, no? What is the difference between alkane and alkyl? Alkane and alkyl. When do you get alkyl and when do you get alkane? This should be clear when I tell you alkyl group. Alkane are the one which is having all the four hydrogen. Yes, like for example, in the case of methane, CH4. If you remove one hydrogen, yeah, one hydrogen less. Very good, correct. So if I write this as one bond here, that one bond will be satisfied by some of the group and one hydrogen less, CH3, then this will become alkyl. So here the simple one I've taken, that is methyl. So one hydrogen less than the alkane is called as alkyl. Correct, no? Yeah, one hydrogen less. Very good. So here R could be any of these group. Generally we write R. Okay. So it can be CH3 group, it can be C2H5, C3H7 and so on it goes. So just write down this general formula also. That's for haloalkanes. Quickly write it down. It is not given in your notes. As far as I know, it's not there in the notes. General way of writing Rx. Where R is the alkyl group, I'll just write there. Where R is the alkyl group and X is the halo group. Okay. Alkyl group I have given here R. Halogen could be represented as X, which could be fluorine, chlorine, bromine or iodide. Fluoride, chloride, bromide, iodide. Written it? Okay. Next, haloarenes. So haloarenes I have told you it is formed by replacing these. There are hydrogen. It can be from anywhere, okay? That hydrogen you can take it from anywhere. So if you replace one of the hydrogen by a halogen here, you will get X instead of that one hydrogen by removing one or more than one. It can be one or more than one hydrogen by the halogen group. Then they are called as haloarenes. These are called as haloarenes. Generally, how are they represented, students? Generally, we write them as AR, okay? Aromatic group, no? Or aryl group. Yeah, if all the hydrogens are replaced, one or more than one hydrogen, all the hydrogen, even then they are haloarenes itself. Okay, so AR and then X. You can call them as polyhalo compound. Many halogens are replaced, many hydrogens are replaced no, by halogen. So then they will come under poly group. But they are haloarenes itself. Clear, no? AR is the aryl group. This is the aryl group. It's called as aryl halide, and this is the halide group. Halide group, where again you know X can be anything, fluoride, chloride, bromide, or iodide. Shall I proceed now? This much is understood to everyone. If any doubt is there, you ask me then and there. Yes, no? I'll proceed. Okay, fine. Moving on with the classification, students. Classification, first classification you are having on the basis of number of halogen atom. Okay, based on how many halogen atoms are present in this haloalkanes as well as haloarenes, they are classified. Okay, so first one I am taking now. I'll take this methane itself, methane CH4, correct, no? So I'll remove one of the hydrogen by the halogen. So I can write this as CH3 and then X. I'm writing the condensed form. It is understood, no? I have removed one hydrogen and I have replaced it by a halogen. So if you replace only one hydrogen by one halogen, then that is called as a monohaloalkane. This is called as monohaloalkane. Mono means one. One halogen you have replaced. Okay. Now same thing. I'll take this methane and from the methane I will replace two hydrogen. Two hydrogen by two halogen. Then how can I write this? I can write it like this, CH2 and then X2. Correct? I have removed two hydrogen and I have put two halogen in that place. So if you replace two hydrogen by two halogen, then this is called as dihaloalkanes. This will be called as dihaloalkane. If you replace now three hydrogen, I'll remove three hydrogen. So then I will be left with one hydrogen and in that hydrogen place three halogen has come. So X3, CHX3. So this will be called as trihaloalkanes. If you do it for more number, generally we call them as poly. Many, if many of the hydrogens are replaced by halogen, that could be called as polyhalogen compound. Is it clear? On the basis of number of halogen atom, if one hydrogen is replaced by a halogen. I'm just writing that definition. You can write it in the similar way. Okay, it's better if you write, students, organic, no? When you write and study, it will stay in your head. Otherwise it's very volatile. It will evaporate. Okay, so make sure that you are writing along with me. Understand and then write. Don't just see your book. So if one hydrogen replaced by the halogen, that's mono. If two hydrogen, I'm writing here, if two hydrogen is replaced by halogen, then that's dihalo. If three, tetra. If four, all the four is replaced, then it will be called as tetrahaloalkanes. If three hydrogen is replaced by the halogen, then that's trihaloalkanes. Similarly, you can go for arenes also. Okay, that I will display here. See here. In your book, the example is given for ethane, no? You can see C2H5. C2H5X is given. You can remember for methane. Easy to remember for methane. So I took that compound. For any organic compound, you should be able to write. So don't stick to one thing. Okay, you should be able to generalize the thing. So here ethane is taken. From ethane, one hydrogen is replaced. Here see, from ethane, two hydrogen is replaced. And here three hydrogens are replaced. Here they have taken propane. Okay, first two are ethane. The third one they have taken is propane. But you can explain that with one methane itself. Now see the next one, haloarenes. If one of the hydrogen is replaced by the halogen, that is monohaloarenes. If two hydrogen is replaced by the halogen, that's dihaloarenes. And if three is replaced, you could see here, if three hydrogen is replaced by halogen, then that will be categorized under trihaloarenes. Okay, here three, 1, 2, 3 are replaced. I hope this classification is clear. It's easy also to understand. Correct, no? Shall I proceed now? Or do you want me to go back and you want to copy down something? Here, do you want to copy this down? One hydrogen replaced by the halogen. Quickly copy this down. Okay, let me proceed. I hope it is clear till the first classification. Now moving on with the second. See, second classification is where compounds are containing. 1 minute. Compounds containing sp3CX bond. That means the halogen which is there over here, the halogen which is attached to the carbon, okay, that carbon is sp3 hybridized. Based on that, we are studying classification, okay, the halogen, because it is of haloalkanes and haloarenes. So that halogen which is attached to the carbon, that particular carbon over here is sp3 hybridized. Okay, now your doubt is if chlorine has replaced hydrogen, still it is called benzene. Yes, still it is called benzene because that was the original parent, no? Like now see, in this case, what do you call for this CH3Cl? If I have CH3Cl, this will be called as chloromethane. Chloromethane because methane was the original structure there. So one hydrogen was replaced, so that you are putting as chloro. Okay, chloromethane. So parent name has to come, no? Otherwise, we will not understand to which they are attached to, from where they are derived. So that parent name also should come. And then you write that halogen name as well. Okay. Yeah. So we'll get back to this. Compounds containing sp3CX bond means we are talking about the halogen. That halogen attached to the carbon is sp3 hybridized. Okay. In that you are having certain classification. So in that first one I have taken. First one is alkyl halide. So alkyl halide is where halogen is directly attached to the carbon which is sp3 hybridized. Okay. So generally we can write this as Rx. Halogen which is attached to the carbon, that carbon is sp3 hybridized. Now this carbon is sp3 hybridized. This is further classified. Okay, they are further classified into, like this I can write as an example. See, CH3X could be an example. But this is further classified into primary, secondary and then tertiary. Primary alkyl halide, secondary, I'll write just the denotation. Primary alkyl halide, secondary alkyl halide, and then they are categorized into tertiary alkyl halide. Now what is this primary alkyl halide? Primary carbocation, secondary carbocation and tertiary carbocation you have studied, students, last year. First year you have studied about these topics. Do you remember what are primary, secondary and tertiary? What do you mean by primary there? Primary means if I remove one of the hydrogen and replace it by an R group, alkyl group. Okay, yes, very good. One hydrogen is replaced by R group. Excellent. So you all remember. So I'll just remove one hydrogen. I'll put R group there. So I'll get R CH2X. Correct? If it is primary. See that methyl halide which I have taken. See, this is the methyl halide. From the methyl halide, I have removed one hydrogen and I have put one R group there. If you are putting only one R group, then that is primary alkyl halide. Okay, now let me remove two hydrogen and write. If I remove two hydrogen from here and replace it by the R group, then I can write it like this: R, R, one H will remain and one more attached to the halogen. This will be the secondary one, okay, where we have removed two hydrogen and replaced by two R group. Now, if you remove all the three hydrogen and replace it by the alkyl group like this R, 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 and then one is attached to the halogen, this will be called as tertiary alkyl halide. Okay. So, alkyl halide is further classified into primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. Did you follow what is primary, secondary and tertiary? And in all of these three cases, the halogen which is attached to the carbon, that carbon is sp3 hybridized. You see here, this is also sp3 hybridized. This halogen which is attached to the carbon, this is also sp3 hybridized. Even here it is sp3 hybridized. Okay, all of these are sp3 hybridized only. But then they are further classified based on the alkyl group. Okay, and how will you understand which is primary, secondary and tertiary? Keep that in mind. If it is primary, you see that carbon will have two hydrogen attached to the halogen, the carbon which is there, no, attached to this halogen, the carbon which is here, the next carbon which is exactly there adjacent to the halogen, that carbon you should see, that carbon, if it has two hydrogen, sometimes when the group is big, no, children will get confused. So you should see that exact immediate carbon where the halogen is attached. If you find there is two hydrogen, then that is primary. If you find there is only one hydrogen, okay, the halogen to which carbon is there, no, attached to that carbon, if there is only one hydrogen, then that is secondary. If you find there is no hydrogen, then that is tertiary. Okay, no hydrogen ones are tertiary. So just make a note of this quickly. What is primary alkyl halide, secondary alkyl halide and tertiary alkyl halide? So this R could be any group. It can be methyl, ethyl, propyl, any butyl, any group. If you want one example, I'll write it below this. One example I'll write here. See, for primary alkyl halide, it could be the CH3. I'm taking R as CH3, CH2X. This is primary alkyl halide. Secondary one, you see, it will be like this: CH3, CH3 and then one X here. X itself I've taken. I did not replace it by any of the halo group. X itself I've taken. So CH3, CH3 on this side. One hydrogen. And if all the side you find they are having only the R group, like this CH3, 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 all surrounded by alkyl group and one halogen here. There's no hydrogen. Then this is tertiary. So write this example also below. Finished? Did everyone finish copying it down? Did you all follow? Everyone is able to follow what is the concept? Yes, no? So first one, see in this, where the compounds are containing carbon halogen bond, where carbon is sp3 hybridized, in that first classification is of alkyl halide. So what are these alkyl halide? Where halogen is attached to the alkyl group. These are alkyl halide. Okay. In that you are having further classification, students. Primary you are having, secondary you are having, and then you have tertiary. So primary means if you remove one of the hydrogen and put an R group, that's primary. You remove two hydrogen, replace it by the R group, then that is secondary. All the hydrogen is replaced by R group, then that is tertiary. Okay, next classification. This is what we did just now. Okay, next one is called as allyl halide. I have put the picture here, but let's understand what is allyl halide. Here also this halogen which is there, the halogen which is attached to the carbon, that carbon is sp3 hybridized itself. Okay, the carbon is sp3 hybridized, but that carbon is attached to next adjacent carbon-carbon double bond. Okay, the next this carbon is there, no, sp3 hybridized carbon is there, no, that's attached to the sp2 hybridized carbon. Then such compounds are called as allylic halide. They are called as allylic. Okay, remember. My voice is breaking. Should I repeat it once again? I'll repeat. No issues. I'll repeat, students. See, what I was telling is, allylic halide are those where the halogen atom which is there, that is attached to the carbon which is sp3 hybridized. Okay, halogen which is attached to the carbon, that carbon is sp3 hybridized. You can see here, this carbon is sp3 hybridized, but that carbon is attached to carbon-carbon double bond which is sp2 hybridized. Carbon-carbon double bond is sp2 hybridized, no? So such compounds if you find, then they will be categorized under allylic halide. They are called as allylic halide. Okay, aliphatic compounds only they are. Aliphatic only, but then immediate to that sp3 hybridized carbon, you will find carbon-carbon double bond. See here example. You can see this halogen, this green one halogen is attached to this carbon over here is sp3 hybridized. But that sp3 hybridized is attached to carbon-carbon double bond. Okay, here 2 hydrogen will be there, here 1 hydrogen will be there. If you want, I'll write it once again. See, halogen. We'll take one example. Chlorine, if I take. Attached to the carbon, sp3 hybridized, which in turn is attached to carbon-carbon double bond. Now you satisfy the valency. How many valencies I need to satisfy for the carbon? Here how many? 2 are already satisfied. So that means I need to put 2 hydrogen here. Here you see 1, 2, 3. Already satisfied with 3. So 1 required. This carbon has 2 bonds. So 2 hydrogen. Okay. So if you find a halogen attached like this CH2, then CH double bond CH2. Then these are called as allyl. This will be called as allylic chloride. This one is allyl chloride. Allyl chloride. Take down the example. I'll repeat this concept. See, for allyl halide again it comes under halogen which is attached to the carbon. That carbon is sp3 hybridized. Okay, remember that. So here the halogen which is attached to the carbon, see here this halogen I'm talking, I'll circle it. The halogen which I'm talking over here, that is attached to the carbon. That carbon is sp3 hybridized, which in turn is attached to the carbon-carbon double bond. Okay, you will find that carbon is attached to carbon-carbon double bonded compound. Then they are called as allylic halide. There's a name given for it. For a compound which is having different kind of arrangement, they have given one name. So they have found that this halogen is attached to the carbon which is sp3, but that is in turn attached to carbon-carbon double bond. So they name them as allylic. You can remember in this way. See, allyl, aliphatic compound. So initially it is single bonded. Allyl double L is there. So you can remember there should be a double bond immediately after that. Aliphatic means single bond. But then you can see there is allyl when you are writing, double bond is there. So you can keep that in mind and remember this. Later on, again, I will ask you. So then you will be able to remember it in a better way. So just write down one example. Below this, you write this example. Allyl chloride. Okay, allyl chloride is Cl, then CH2, CH double bond, CH2. You make a note of this also. This, the way I have written it, no? Halogen attached to sp3 hybridized carbon, which in turn is attached to carbon-carbon double bond. That carbon is sp2 hybridized. Write it in that way. So then remembering the concept will become easier for you. When you have short notes in your hand, remembering will be easier. Otherwise, you will have to read that entire thing. Okay, done. Shall I proceed? Yeah. Okay. Even this could be one more example. See this which I have displayed here. That is also allylic. It is not benzene related compound. It is not benzene. Aliphatic only it is. See, you can see it is just a closed ring compound. It is just a closed ring compound, but then they are coming under allylic category because you could see here this halogen which is attached to the carbon. This carbon is sp3 hybridized because single bond everywhere. After that, this carbon is attached to carbon-carbon double bond and there is only one double bond. Okay, so this is allylic itself. It is not benzyl. Benzene ring is not there. So don't get confused like that. Because only one double bond is there. So their properties will be similar to aliphatic compounds. Okay. Yeah. Next one. Next one we are having is benzylic. Okay, next category, next classification. So in benzylic, the difference is, students, here halogen is attached to the carbon, which is sp3 hybridized. So I'll just mention this halogen which is attached to the carbon, that is sp3 hybridized. But in turn, that carbon is attached to the benzene ring. Okay, this carbon is attached to carbon carbon double bond only, but then that carbon carbon double bond is not just a simple compound, they are benzene ring, so then they are categorized as benzylic halide. Okay, so here these are the compound where halogen is bonded to the carbon, which is sp3, which in turn is attached to a benzene ring. You can even call them as aromatic ring, any aromatic ring, if they are attached to, if they are attached to aromatic ring. Okay, so here if you want to satisfy, you can put 2 hydrogen, then you will get the exact stable compound with all the hydrogen being satisfied. Okay, that's benzylic. See, only difference between allylic and benzylic is this. Here it is aliphatic compound and here it is aromatic compound. That's the difference. Otherwise, it is similar. Fine. So you just mention what it is. Here halogen is attached to sp3 hybridized carbon, which in turn is attached to a benzene ring. So those are called as benzylic halide. Shall I proceed? Is it done? You can take one example, okay? Instead of taking that halogen, I'll take one example here and write. Instead of X, you can write one example. Benzene ring is there, and then you are having CH2 group. Then after that, we will take chlorine. So this will be benzyl chloride. This is benzyl chloride. Okay, the name of this compound. Benzyl chloride. Benzyl group is benzene ring with CH2. Benzyl group, remember, benzene with the CH2 is benzyl. Okay, next classification. This is what we have finished. Next one, compounds containing sp2 hybridized CX bond. Means the halogen which is attached to the carbon, that carbon is now sp2 hybridized. Okay, now it is sp2. The initial one what you had was sp3. So in that first category is vinylic halide. So vinylic halide is where halogen is attached to the carbon. That carbon is having a double bond. Carbon carbon double bond is there. So if they have a double bond, then that is sp2 hybridized carbon. No. So here halogen is attached to the carbon. That carbon is sp2 hybridized. Okay. So this will be the example. If I want, we can replace it by a better example. So you take chlorine here and then you are having carbon which is having a double bond. So there should be a carbon-carbon double bond. Then satisfy this. 1, 2, 3 bond was already satisfied. So I have put 1 hydrogen here. And this 2 bonds were already there. So I will put 2 hydrogen. Okay, so this will be called as vinyl chloride. This one is vinyl chloride. You have heard about polyvinyl chloride. PVC you have heard, students. PVC pipe you have heard. PVC pipes. Polyvinyl chloride is the full form of that. So that PVC pipes are made up of this vinyl chloride compound. This vinyl chloride combines. When many vinyl chloride combines together, that will give rise to a polymer which is polyvinyl chloride. Okay, so this is the monomer of that. This is the initial unit which will further combine. Okay, so what is it? Where halogen is attached to the carbon and that carbon is sp2 hybridized, or you can say that carbon atom is having carbon-carbon double bond. Okay, write the example as well. Write the example. Everyone, is it done? Okay, next classification in this. After vinyl, you are having aryl halide. Aryl halide is if halogen is directly attached to the aryl group, that is benzene, aromatic ring. Okay, AR. Remember, AR is for aromatic ring. Aryl group is again aromatic ring or arenes. So if halogen is directly attached to aromatic ring or benzene ring, then that will be called as aryl halides. Okay, example I can take here, benzene ring with the chlorine, direct attachment. Direct attachment of that chlorine atom to the benzene ring. Okay, that's aryl. So chlorobenzene. Chlorobenzene is the example. Chlorobenzene. Write down the example here. Halogen is directly attached to aromatic ring. Aromatic ring. These are the different classifications. Okay, based on they have seen that this halogen attached to different categories of carbon compounds. So this classification has come into picture. I hope you are able to remember now this, all of these. Let me revise this quickly. I'll revise this. Okay. So all together, I will put everything together and then we can revise. I hope it's done, students. Done, no? Just give me a clue that you have finished. Then I will just revise once again, everything together. Why this classification came into picture? That's because of these halogen which are attached to the carbon, no? That carbon is of different varieties. Some are having just single bonded, some carbons are single bonded, some carbons are double bonded. So based on that category, this classification has come. Okay, you can say it is based on the variety of carbon. Double bonded carbons are there, single bonded carbons are there, aliphatic is there, aromatic is there. So depending on that, we can find different classifications. Benzylic slide, is it? Okay. I'll put everything together and explain. So I'll get back now. I'll come back to this. See, first one was easy. First main classification based on number of halogen atom. That was easy, correct? If there is one halogen, that's mono. If there is two halogen, that's di. If there is three halogen, that is tri. So I will not touch on that because that was easy. If you look into the example only, you will be able to understand. I'll directly start with, you had compounds containing sp3 hybridized carbon halogen bond. Means the halogen which is attached to the carbon, that carbon over here is sp3 hybridized. In that you have seen there are three classification, correct? First one is alkyl halide. First one was alkyl halide. Second one was allylic halide. Second was allylic halide. And third one what we saw was a benzylic halide. Okay, so these are the three classification. So if you see first one, alkyl halide is normal. Halogen is attached to the alkyl group, R group. But this R group, like for example, if I take CH3X, that H could be replaced. No, it can have branch. You know that carbon cannot be alone. Okay, this could be one variety, but then that carbon can again have a branch. You know, they can have a catenation. They have a catenation tendency. So they can have a branched compounds also. So based on that, if there is one alkyl group, one R group present. Okay, if I remove this one hydrogen and put one R group, then I'll get RCH2X. If I replace it by two hydrogen, if I replace it by two alkyl group, then I'll get R2CHX. I have condensed and I have written R2. 2R group I will have one hydrogen and then one halogen. Total 4 bonds. Then if I remove all the hydrogen by alkyl group, so R3, C and then X. Okay, so depending on this, how many alkyl groups are being added in the place of hydrogen, we are having primary, then secondary, and then tertiary alkyl halide. If there is one R group, then it is primary. If there is 2R group attached to the carbon, then that is secondary. If there is 3R group attached to the carbon, that's tertiary. This was clear, I believe. Alkyl halide portion was clear and classification was clear. Yes, okay. Then next was allylic halide. Allylic halide is, remembering also, you remember in that way. Al means aliphatic it has to be. Double L is there. So remember there should be, after that double bond should come. Okay. So here halogen was attached to the carbon. That carbon is single bonded, aliphatic. Okay. But then that carbon is attached to carbon-carbon double bond like this. I have not satisfied the valency here. So you can remember in this way. Halogen is attached to sp3, which in turn is attached to sp2 hybridized carbon. Okay, this is allylic. Then you write one example. If you know the skeleton structure, then you can put the hydrogen, no, by satisfying the valency of carbon. Okay, that was allylic. Allylic and benzylic are of similar category. Only difference is here it is aliphatic compound, there is aromatic compound. Okay, so here also halogen is, see in benzylic, here also halogen is attached to sp3 hybridized carbon itself. But that sp3 hybridized carbon is in turn attached to a benzene ring like this. Okay, so that's the only difference. Here the group is aliphatic group, this one, this is the group aliphatic group here, double bond, and here the group attached to the carbon is a benzene group. Okay, so it is benzylic and this is allylic. Clear, no? It is same category ones only. Only this is a difference. Then we had compounds containing, the last category of classification, compounds containing sp2 hybridized carbon halogen bond, means the halogen which is attached to the carbon, that carbon is sp2 hybridized. So based on that you are having two classification. One was a vinylic halide, and the other one was aryl halide. One was vinylic halide, other one was aryl halide. Vinylic halide, where halogen is directly attached to, it is sp2 hybridized. That means carbon-carbon double bond directly. Halogen is attached to carbon-carbon double bond. And here aryl halide. So aryl group has to come, means aromatic group has to come. So halogen is attached to aromatic ring or benzene ring. Okay. This bond you can put in the vertex like this way. Done. Okay, clear, no? Vinylic and aryl halide. So that's all. These are the classification. Then you remember the example. Hope it is clear, students. Shall I proceed? Shall we proceed with the next important part of it? I have condensed everything, no? I have given everything. On the whole, I gave you the gist of this. Let's proceed now. Let us not waste the time now. Moving on with the nomenclature. You know, nomenclature is naming the compound, giving the name. There are two ways you can give the names, no? One is common name and the other one is IUPAC name. So we have a common name is there, and then we have IUPAC name. You have learned this before and you know the rules also. The initial rules what you have learned in first year and which I did in the beginning of this second year also. Hope you all remember those. No, one class I have spent there explaining you how to name the organic compound. So try to recall all that. You'll be applying it right now. Okay, so nomenclature, there are two categories of naming the compound. One is common name and the other one is IUPAC name. Okay, both becomes important. At least for simple compound, you should know both the names. Common name as well as IUPAC name. Okay, now what are the common name? There are two categories. No, one is haloalkanes and you are having haloarenes. So haloalkane itself is the IUPAC name of this haloalkanes. Okay, and haloarenes is actually the name IUPAC name. Okay, haloarenes is IUPAC name. Haloalkane is the IUPAC name of these compounds. And what is a common name for haloalkanes? The common name is alkyl halide, alkyl group attached to it. So common name is alkyl halide. And for haloarenes, the common name is aryl halide. Yes, aryl halide. That is a common name. Okay, so this is the common name and that's the IUPAC name. So you can make a note of this quickly. If you write along with me, naming, no, do along with me. Don't refer your book. If you just see your book, no, I don't think so. You'll be able to get a practice. You should get a practice by writing. So write along with me. Clear alkyl halide, common name, haloalkanes, IUPAC name. Aryl halide, common name, haloarenes, IUPAC name. Rest of the rules remains the same. The way you are going to name it is the same how you have done in first year. If there is a branch present, you should name the branch. Okay, if there are two branches present, then you should make use of the prefix. Similar branches, if they are present, then you should make use of the prefix like die, try, all that remains the same. So I'm not going to touch on that. We will directly go with the example. Okay, so I'll write the example here. The compound name I'll write here. Then we will write the common name, followed by we will write the IUPAC name. Let's see how to give the names of these. See, these are the compound. I'll be writing the compound here. Then we will give common name. Not all the common names are important to remember. At least simple ones you should know, students, because otherwise it will be difficult for you. Especially when you are having named reactions, no? You should know common name as well as IUPAC name. Then last one, last column, I'll give it for IUPAC name. Draw this column along with me. One for compound, one for common name, and one for IUPAC name. We'll start with simple compounds first. Try to name them. Then we'll go for complicated one. Okay, starting with first one. Start with first one. What will be the first one's name? Common name. Yeah, common name is what? Alkyl halide. So I will write that name also here. So that you know you are supposed to name the alkyl group followed by the halide name. And IUPAC name should be haloalkenes, because now I have taken only alkanes. Haloalkenes only I have taken. When haloarene part comes, that time I'll write that name. Yeah, now first one, very good, correct. First one is a methyl group, no, CH3 group. CH3 group is methyl group, correct. Methyl and then followed by Cl group. So methyl chloride, very good, correct. So we can write starting letter, let it be capital, methyl chloride. Alkyl group is methyl group because one carbon. Okay, and here IUPAC name. The halogen which is present over here is Cl. So halo, chloro. One carbon alkane it is. One carbon alkane. So methane. Chloromethane. No doubt, no, everyone able to follow this. How to give the name. Okay, go with the next, second one. CH3Br. CH3Br. CH3 again. Methyl group. Yes, methyl. So methyl. Methyl then what? Br. Bromide. Yes. Methyl bromide. IUPAC name. IUPAC name should end with alkane. Bromomethane. Starting letter should be a capital letter. Make a note of that. Bromomethane. Bromomethane. Yes, very good. Correct. Correct. Third one. First this is second, this is third, this will be the fourth one, this will be the fifth one. Third one, what will be the name, students? Yeah, correct. Propyl iodide. Correct. 3 carbons. So propyl. Very good. Propyl iodide. IUPAC name? Iodo. Correct, no? Halo is iodo here. You should end with O. Iodo and 3 carbons. So propane. Iodopropane. Correct. Iodopropane. Okay, next. Fourth one. You see how to name this. Fourth one. Fourth one you need to number because there is a chlorine which is coming in the second position. You can see there. Common name, I'll tell you what common name it is. But when you are naming the IUPAC, you have to number it, no? Because you could see that chlorine is coming in the second position. 1, 2, 3. Second position. Longest chain has to be selected, no? So what will be the IUPAC name? Let me write the IUPAC name first. IUPAC name for this will be 2-chloropropane. Yes, very good. Correct. 2-chloro. Second position is the chloride group. You can see here. So 2-chloro. Then 3 carbon. Alkane name should be followed by the halo group. So 2-chloropropane. Okay, now come to the common name. What will be the common name for this? So if you see the halogen to which that carbon is attached, you can see here this carbon, students. On both the side, what you are able to see? There is methyl group, which is nothing but the R group. So what type of classification is it? What kind of classification is this? If you are having R group on both the side, 2 R groups are there. Yes, very good, correct. That is secondary. Yeah, so this is secondary. Secondary, you need not write the whole thing. SEC is enough. Secondary, 3 carbon is there, no? So secondary propyl chloride. It can be secondary propyl chloride, or there is another way to name, because this is one exceptional case which can have 2 common name also. Okay, one is secondary, the other one is anytime when you see CH3 and then CH and a CH3 group like this. It can be in this branch form or if it is given in a straight chain fashion, anyhow. This I will keep as vacant. Okay, one, it will be attached to something. So if you find in this fashion, so then that is called as iso. Remember, second position, if you are having CH3 group attached, second position, this is first position, this is second position. So second position, whenever you find a CH3 group present, then that will be called as iso. Okay, so this can also be named as isopropyl chloride. Isopropyl chloride or secondary propyl chloride. Both name is possible by this. For propyl, it is possible. Okay, it's an exceptional case. Is it followed what I said? When you name them as iso and when you name them as secondary, be very clear with this. Iso means if you find a CH3 group, then second position there is CH group and attached to that one CH3 group is there. Second position CH3 group, if it is there, then that is iso. Okay, in this fashion, it should be in this fashion the way I have given here. So just have a note, write it in your book. Secondary means the halogen to which that carbon is attached. No, that carbon should have 2 alkyl group attached. You can see here one alkyl group on this side and another alkyl group on the other side. Okay, so then this will be secondary. So here 2 names are possible. Secondary is also possible, iso is also possible. By default, it is coming like that. Okay, now come to the fifth one. Fifth one, what will be the name? Isohalogen is over here. See here, here is the halogen. Now in this compound, halogen is over here. Otherwise, it can be anywhere. Anywhere it can be. Iso means you should just have CH3, CH and CH3. Then that will be iso. This one, the fifth one, correct. Butyl, correct. 4 carbon, no? Butyl chloride, agree. Butyl chloride, it is also named as N-butyl chloride, okay? See, I'm adding one N here. What does that N stand for? N stands for normal way of writing, straight chain compounds. When you are writing straight chain compound, for a common name, they add N there. Because isomers are possible, no? Otherwise. So N-butyl chloride means the compound is a straight chain compound. Okay, and here IUPAC name, yeah, very good, correct. Chlorobutane, yes, 4 carbon, so chlorobutane. Okay, now I'll give you the next one. You should tell me what is the name of that. The common name as well as IUPAC name. So I'm writing here CH3. Here I'll put the Cl. Here CH2 and here CH3. Tell me what will be the name of this. CH3, CHCl I've taken here. Then I've taken CH2 and then CH3. Think properly and then give the name. I'll give you half a minute time. Think properly and tell me what will be the common name as well as the IUPAC name. Yes, very good. Correct, correct. Secondary butyl chloride. Everyone is saying secondary butyl chloride. Any doubt in secondary and iso? Do you all have a doubt for secondary or iso? Is that a doubt to anybody? Okay, now let me see if you are having another compound. What will be the name of that? Okay, I'll write it over here itself. Tell me for this. You tell me which one is what? Sixth one and the seventh one. I've put together one by one after the other. I've written here. So you should tell me which is iso and which is secondary. Sixth and seventh. No, what is sixth in that? And what is seventh in that? Hmm. Yes, very good, correct. So that means the concept is clear. Now is the concept clear? Which is iso and which is secondary? So see here. See, listen here. In case if you all have any doubt. Sixth one. If you see sixth one, students, see where the chlorine is. Halogen. You see that halogen atom. See, halogen atom is over here. And that halogen is attached to the carbon. That carbon is having only one hydrogen. That means this side there is one R group. This side there is another R group. Correct? You should see the halogen first because you are talking about haloalkanes classification. So halogen which is attached to the carbon, that is having two R group. That means this has to be secondary. No doubt in that. Correct? Now come to this one. Seventh one if you come. Here halogen which is attached to the carbon, that carbon is CH2. See there, that carbon is having CH2. That means this becomes the entire R group. This is the R group. So this is actually primary. Correct? No? Primary it is. And here if you see CH3, CH and second position there is CH3 group. Then that will be called as iso. So this is isobutyl, common name. I am talking about the common name. This is isobutyl chloride. Isobutyl chloride and this is secondary butyl chloride. This one. This one is secondary butyl chloride. No doubt, no? For everyone. Which is iso and which is secondary? Iso means you should have CH3, CH and CH3 group coming in that chain. Okay. So here you can see that CH3, CH and CH3 group. You can see that group here. So then this group, if they are coming, that is iso. CH. For it will come like that only. Okay, whenever you are having iso group, it will be like this. CH3 you will have, CH you will have and CH3 you will have. Always a continuous chain. Second position you will have CH3. Whenever you find a group like this, it is iso. Now tell me the IUPAC name. Common name you have written. See, I don't have place here. I need to manage here itself. Now tell me what is a common name. For this sixth one, what is the IUPAC name? What is the IUPAC name you have written? 1, 2, 3, 4. Correct, no? You should see that the branch should get the least possible number. So 2-chlorobutane. Correct. 2-chlorobutane. Correct, correct. 2-chlorobutane. I am writing here itself, see, because I don't have space. You should write one below the other. Write common name separately and IUPAC name separately. Okay, so 2-chlorobutane. Come to this one. Seventh one, what is the name? Seventh one, what is the name? Seventh one, when you are naming, see where is the halogen present. Halogen and then one is CH3 group, branching. So, first number should be given to this. Both are branches only, Cl, and both are prefix CH3 and Cl. But in that, Cl alphabetically comes first. So, it should be 1-chloro. Second position will be methyl. Longest chain is this, no? 1, 2, 3. First position chloro. Second position, what you are having? Methyl. So, it should be chloro. 1-chloro. Need not write 1. Chloro. 2-methyl. Agree? Yes, 2-methyl. Then in the parent chain, what is the longest chain? Parent chain. How many carbon chain it is? 3 carbon chain it is. So 3 carbon chain is propane. Agree? So chloro 2-methyl propane. Yeah, correct. Good. Is it followed? Everyone? Understood how to name students? ISO, secondary, everything is clear? Few more example. No, you need to work out few more only, then you will be thorough with it. Let me give you few 2 or 3 example. Let us work out little more. See this one, CH3. Yeah, attached to the halogen where it is attached to that carbon, no, you should see that carbon. With respect to that carbon, how many R groups are there? Okay. Attached to that halogen, which carbon is there, that carbon you should see. Okay, next one. This is eighth one, no? 7 till 7 you have done. Eighth one. Sorry. Don't look into your book now. Just try to concentrate on the screen. The example which I have displayed here. Try to work out by yourself. See if you're getting answer. If you're trying to get the answer. Eighth one. Could you answer eighth one? You could see here Br is attached to the carbon and that carbon is having 3 CH3 group. If you want, you can write the open structure. This is how it will be, no? BrC and then this C is having 3 CH3 groups. So 1 CH3, 2 and then 3. Yes, very good. Correct. Correct. Answer is correct. What you said. So others also reply. Tertiary it is. Yeah, correct. Tertiary is the name because carbon is having 3 R group attached. And total how many carbon atom? 4 carbon atoms. So it is butyl, okay? Tertiary butyl. Tertiary you can just write as T. Need not write everything. Tertiary T is enough, okay? T. Small t is enough. Tertiary butyl bromide. Tertiary butyl bromide because alkyl halide is the name. So tertiary butyl bromide. Okay, now come to the IUPAC name. How will you give the IUPAC name to this? How will you give the IUPAC name? Select the longest possible chain. Which is the longest possible chain? The first rule of organic compound. Select the longest possible chain. So which chain I am supposed to select? Should I go vertically or horizontally? Vertical or horizontal? Vertical, no? Vertical, right? Like this, 1, 2, 3. Because I'll get the longest possible chain here. 3, yeah, 1, 2, 3. If I take this as the longest chain, students, see where I have numbered it as 1, 2, 3, then these two will become a branch. You all agree with me? If I take this vertical column, okay, where I am having 3 continuous carbon atom in the chain, then these two will become branch. And one branch is Br, the other branch is methyl. So which should be written first? Horizontal, you will get only 2 carbon. If you are taking horizontal, then it should be 1 and then 2. You will get only 2 carbon. That's wrong, no? Longest possible chain has to be selected. So I have selected that longest possible chain. There is another way you can number it. You can take this chain also. This one. This way. You can take this chain also. That is fine. Okay. The way I have drawn that L shape, no? Ulta L, see the L that you see. See, you can take in that way. But you should take maximum 3 carbon atom because 3 carbon atom will be forming that longest chain. So I have gone straight here. 1, 2, 3. So second position you see there is Br also branching and there is CH3 also branching. Which comes first? Alphabetically, bromo comes first. So it should be 2 bromo, 2 bromo, second position again, 2 methyl. Don't forget to mention that number. How many branches are there? That many numbers should come. So 2 bromo, 2 methyl. So done. Branch name is done. Now come to that main chain. Main chain has how many carbon? 3 carbon atom. So 3 carbon atom means propane. Correct? So 2 bromo, 2 methyl propane. Agree? Understood? Got how to name, students? Any doubt? Any doubt is there still which is going in your head? You can ask me. Okay, clear, no? We'll go for next one. Next one you try to name. Next one you see Cl is attached to CH double bond CH2. If the halogen, let me see if you are able to name this. If halogen is attached to carbon-carbon double bond, what type of halide is that? Under which classification have you studied this? What type of halide is this? If halogen is attached to carbon-carbon double bond, you can see here it is carbon-carbon double bond. Which one is this? Halogen is directly attached to sp2. Halogen is directly attached to sp2. Yeah, vinyl, no? Vinyl, no? Vinyl. So it is vinyl chloride. Vinyl. sp2, no? Vinyl. And Cl is there, so vinyl chloride is the name. Okay? Vinyl chloride. Vinyl chloride. That's the common name. Okay, now come to IUPAC name. IUPAC name, to give the IUPAC name, one chlorine here. That chlorine is attached to, see here, carbon-carbon double bond. Halogen is also there and double bond is also there. So give the number to that carbon first. Don't go from here. You can't start from the left to right. Better you start from right and go to left. Because that carbon has added advantage. It is having the halo group also and double bond also. If you take this carbon, this has only a double bond, no halogen. So who should get more weightage? The carbon which is having double bond as well as the halogen. So I am giving first number to this. Okay, 1 and then 2. 1 and 2. So first position there is chlorine, correct, no? Chloro, yes, chloro. And then double bond, yeah, ethene, very good, correct. So chloro, double bonded carbon, no? 2 carbon with double bond. 2 carbon with double bond is ethene. So chloroethene is the name. Yeah, 1 chloroethene also you can write, correct. 1 chloroethene is also correct. Is it given ethene only in the book? It's not ethane, no? Because I remember last year there was a printing mistake. This time you just check if it is ethene or ethane given in your notes. Then correct it to ethene. It is ethene. Ethene, no double bond. So ethene. That was a printing mistake. So correct it, students. Correct that. Okay, go for next one. 10th one. 10th one. Quickly. 10th one you see here. Halogen is attached to. Very good. Halogen is attached to sp3 carbon. You can see here bromine is attached to sp3 carbon, which in turn is attached to sp2. So that's allyl. Yeah, that is allyl. So this is allyl bromide. Allyl, okay, just allyl. Allyl bromide. Allyl bromide. Now come to the name. Numbering. From where will you start the numbering? Left to right or right to left? Numbering when you are doing. Right to left or left to right? Right to left, is it? Why will you number this bromine first? You want to number this first and this second and this third, is it? Do you all remember that order which I gave you? What should come first? Carboxylic acid should come first. Then you have aldehyde. Then you have ketone, all that. Last you tell me what comes after that. Double bond comes. I will not write all that. Functional group is not there, no, no. Functional group is not there. After that double bond comes, then you are having triple bond. After that, all the prefix, all the branch, all the substituent will come afterwards. So now here bromine is a branch. Bromine is the branch. So double bond should be given first preference. Getting the point? So how should be the numbering? Now tell me, left to right or right to left? Now it should be left to right. Left. 1, 2, 3. So third position you will have Br. Third position Br means 3 bromo. Correct? 3 bromo. 3 bromo, and then you are having 3 carbon. 3 carbon is propene. Correct. Propene. So 3 bromo propene. I think again in your notes they have given propane. So correct it. Propene it is. Yeah, it should be propene. It's a mistake. It's a mistake. Printing mistake. You write propene. 3 bromo propene. Done, no? Okay. Few more. Is it clear? Any doubt you all have? Do you all have any doubt in this IUPAC? Anything to ask? Any confusion? Here your doubt was like why to number as 1, 2, 3, is it? Eighth one? Eighth one, longest possible chain. See, 1, 2, 3, longest possible chain has to be selected. So after you select that longest possible chain, which will come as a branch? The remaining will be taken as branch. No, Br will become a branch. CH3 will become a branch. Now when you have two substituent which are branches, both are branch, okay? Both are having equal weightage here. So which one should be written first? The one which is coming alphabetically first, that should be written first. Alphabetically, whichever comes first, that should be written. Okay. So bromine comes first. No, bromo comes first. So 2 bromo. And second is methyl. Second position itself both are present. So 2 bromo, 2 methyl. Propane. Clear, no? 10th one you are numbering from left to right because of the double bond. Double bond should be given first preference, functional group. And the prefix should be given last preference. Functional group always should come first. Double bond is more reactive than compared to Br. In ninth case, if you see this carbon, the first carbon which I have labeled as first one, that has a double bond also, and this side there is chlorine also, no? So that should be given first number. N stands for normal. When you are writing, okay, fifth one, here I had given you N. N-butyl. N stands for normal way of naming it. Straight chain compounds when you are naming, that is N-butyl. Yeah, here double bond and bromine. So this will have more weightage, okay? You should give first preference to this because that has a functional group. Double bond should get first preference. After that, the function, the branches, sorry. You need few more example. Yeah, I'll be giving you few more compounds will work out. See this one. Some are there in your notes that also I will take because in case if they ask in the exam, you should know how to name this. This you try. 11th one. 12th one is CHCl3. Try giving these. You give the names. Thirteenth one. 11, 12, and 13. Common name, it's okay. If you don't know the common name, that's fine. You try to give me the IUPAC name. Try to give me the IUPAC name. Yeah, very good. Correct. CH2Cl2 is two chlorine group are there. So dichloro and one carbon. So dichloromethane. Yes, very good. Correct. Got no? Why that 11th one is dichloromethane? See here, two chlorine are present. And two similar kind of branch they are. So you should use a prefix di. So it is dichloro and one carbon. So methane, dichloromethane. The next one, it has three chlorine atom attached. So if you are having three chlorine atom attached, trichloro. So it will be trichloro. This will be trichloro, one carbon. So trichloromethane, trichloromethane. If suppose I had given you CCl4, then that will become tetrachloromethane. In case if I had given you like this CCl4, okay, 14th one, let me add this also, CCl4, then this is tetrachloromethane. Tetra, tetrachloromethane. Tetrachloromethane will be the name. Okay. And now common name, you can just remember students, if it is CH2Cl2, it is methylene chloride. Okay, this one is methylene chloride. You can just remember because this they won't be asking you the common name as such for this methylene chloride, but at least have in your mind. That's because of this CH2 group. That CH2 group is called as methylene group. So it is given that name, methylene chloride. Two chlorine atoms are there, no? So if they give methyl chloride, then it will become CH3Cl. So they gave this name, methylene chloride. And this one, the 12th one, that is chloroform. Chloroform. Okay, trichloromethane is chloroform. Okay, now go for that 13th one. 14th one is carbon tetrachloride. Okay, if you want the common name, that's carbon tetrachloride. Carbon carbon tetrachloride. Tetrachloromethane is the IUPAC name. This 13th one, how will you name? Common name, you forget. I want the IUPAC name. Just try the IUPAC name. This is clear, no? When to write a neo and when to write a iso and everything. Neo, I told you, if that carbon is surrounded by all the remaining carbon atom, then that will be neo. And then count the number of carbon atom. 5 are there, so pentyl. Then Br was there. Tertiary means you will have, see, tertiary, the difference between neo and tertiary. Tertiary will be like this, no? One carbon here, then you will have CH3, CH3 and CH3. That's it. Three side you will have 3 R group. And the other one will be bromide. So this becomes tertiary. Here, what is the change you are able to find? There is in between one CH2 group. See here, this CH2 group is there here. Immediately next to the carbon, there is a carbon. So then that's neo. Okay, if it is halogen, then that will be tertiary. That is the difference between tertiary and neo. Yes, good. Good that you people are asking. Only then the things will get clarified, no? Okay, quickly we'll finish even the haloarenes naming also, students. Then we will wind up for today. Okay. Yeah. So When you are naming for haloarenes, benzene related compound, for common name you need to know the positions, correct? Benzene, if you are having, you should know the positions. Do you remember for common name I had given you the positions? There is a name given for those positions. If you have the halogen atom attached over here, this position will be called as a para position, correct? No, immediate next position is ortho position. Even this one, immediate next to para is ortho position. Very good, correct. This is meta position. Yes, you all remember. This is also meta position, and opposite to para you are having para position. Yes, correct. That is utilized when you are giving the common name. This ortho, para, meta we will make use when you are giving common name. So if I label this as 1, first, second, third, then fourth, and this is fifth, and this is sixth. So with respect to 1, see position 1 and 2. Always position 1 with respect to 1, second position will be ortho position. Or with respect to 1, sixth position. With respect to 1, sixth position is ortho position. Okay, 1, 2 and 1, sixth position is ortho position. 1 with respect to 1, third position. With respect to 1, third position, that is meta position. Or with respect to 1, fifth position. With respect to 1, fifth position, that is meta position. Okay, and then 1 and 4 position, that's para position. So you should see wherever that halogen is, with respect to that, in which position this another halogen is present. Okay, if you have to give ortho, meta and para name. When there are two halogen, we make use of this ortho, para and meta. Otherwise, it is not required. Okay, when there are two substituents, no, then it comes into picture. Just make a note of this. See, now if I give you this compound, you should tell me what will be the name of this. What do you think will be the name of this? Here is the halogen atom. So if this is the halogen atom, this will be the first position, second position, third position. So 1 and 3 position is which position, students? Meta position, no? Correct. So this will be called as meta dichlorobenzene. Meta dichlorobenzene. Okay. This is meta dichlorobenzene. 2 chlorine atom is there. So meta dichlorobenzene. So meta stands for that position 1 and 3. If you are giving IUPAC name, then this will be 1, 3. First position is this, second position is this, third position is this. So it will be 1, 3 dichlorobenzene. See, that is the only difference between common name and IUPAC name. For common name, we make use of that letter, and in IUPAC name, we make use of that position. Numbers are given. Okay, no? Just make a note of this position, then we will take example. Done? Okay. Done, no, everyone? Everyone has finished. Shall I proceed? We'll take the example directly. Okay. So try to name this now. Common name as well as IUPAC name. Common name we will write first. Common name. Then IUPAC name. First common, then IUPAC. Yeah, common name will be, yes, immediately, no, after first, second position. So ortho, correct. Ortho dibromobenzene. Yes. Ortho dibromobenzene. That will be the common name. And what will be the IUPAC name? Position 1 and 2. So 1, 2. Position you should mention for IUPAC. 1, 2 dibromobenzene. 1, 2 dibromo 1, 2 dibromobenzene. 1 minute. Okay, yes. Next one. Forget about the common name, go with the IUPAC. IUPAC, how will you give? First position is this, second position for CH3. Because methyl and chloro, if you are taking chloro, should come first. Alphabetically, chloro comes first. So chloro, second position is methyl. So it will be 1. If you want 1, you can write. Otherwise, you need not write 1. You can directly write chloro. So it will be chloro, yes, 2-methyl, correct. Chloro, then 2-methyl, 2 has to be written, 2-methyl, followed by benzene. No, they are attached to benzene ring, so ending name should be benzene. Chloro 2-methyl benzene. And common name is, you can take CH3 with benzene as toluene. If you take benzene, if you have benzene attached to CH3, you know that is called as toluene, no? Commonly we call them as toluene. So if this is toluene, chlorine is attached at second position. This entire group is toluene, benzene with CH3. So with respect to CH3, chloro is in ortho position, second position, ortho. So it is called as orthochlorotoluene. So it is called as orthochlorotoluene. Okay, trying to make it short and writing it. Toluene for methyl and benzene together, toluene. With respect to that, you find chlorine is in the ortho position, so orthochlorotoluene.